Welcome to this Simplygon demo. We're going to take the help of our friend Polly to guide us through the park of Simplygon features. Simplygon has, since its inception in 2005, been the gold standard for 3D optimization. Over the years, our technology has been used in the development of more than 450 titles. Games like Halo Infinite have used our SDK to help their creations run at target frame rate. Through this demo, we will explore the core features of Simplygon and look at how they can help optimizing massive environments like the ones we find in Halo. Our first stop on this walk is our Imposter technology. Traditional polygon reduction tends to struggle with geometries like this gate, fences, wires, and other types of thin objects. With the Imposter, you can project these kinds of objects onto textures that works better as a cheap, faraway representation. And if we zoom out here, you can now see that when we switch between these two, actually the Imposter looks better. Let's move on to the next feature, LOD chains. Here we can find 4 versions of Poly, where the 3 last are heavy reductions of the previous one, of the original one. You can see that if we look at the wireframe here. We have used Simplygon's battle-proven reducer to create this great-looking LOD chain for our robot friend. As we can see, Simplygon preserves deformation zones and other important areas, making the object tolerate scrutiny even though it's built for faraway viewing. Another helpful feature in Simplygon is our bone reduction tool. When you're building games with detailed characters and long view distances, it's quite unnecessary to play animations on parts that aren't distinguishable at a distance. It's just a waste of CPU cycles. If we zoom in here, we can see that Poly's fingers aren't animated in the right hand side, but you cannot see that at the distance. Let's move to the next stop in a quick tour of our Simplygon SDK. Vegetation tends to be one of the costlier parts of a game. Simplygon's billboard cloud can help you cut down the rendering cost significantly. By projecting complex geometry onto a texture and a set of intersecting planes, Simplygon creates a chip representation object, which from a distance works really well as a representation. And your vegetation is a lot cheaper without sacrificing too much visual fidelity. And yeah, we are running through this park fast. If you want to get a deeper understanding, make sure to catch our deep dive talks and our tutorial videos, which you can find on Simplygon's YouTube channel. Let's move on to the next station. The next station on our walk is our visibility column feature. For cases, for example, mobile VR experiences, where you really need to go super low with your poly counts, this can come in handy. By manually or in scripted manner placing cameras in the angles in which an object can be seen from, you can have Simplygon take away geometry that is invisible. This can sometimes save you the few CPU cycles or GPU cycles that needs you to take you over the feel okay barrier in VR. Another way of removing hidden polygons is using our aggregation processor that in combination with geometry culling to produce a hollow shell. This feature is super helpful when you're building your environment using a kit bashing methodology, combining objects into a larger object. This tends to create objects that are riddled with internal geometry, like this one. If we fly through here, we can see that there's a lot of intersections happening internally here. By applying this feature to your kit-bashed asset collection, this geo is removed without affecting the exterior visuals. And here we can see in the cut through that a lot of the intersecting geometries have been removed. The next level of this feature is to merge all materials to further reduce the rendering costs of the kit-bashed asset collection. There are many use cases for this feature. You can use it to merge to reduce the draw cost when an object is viewed from a distance by just merging all the materials into one. It can also be extremely helpful when porting a game to a weaker platform. With a quick operation, you can drastically reduce the render cost of all your geometries. So here we can see for this trash pile that combining all these unique objects into one single object and taking all the materials and combining it into one material makes this object a lot cheaper to render. And if we zoom out here, it's hard to spot the difference between the optimized and the original. The last station of our work is the remesher. Simplygon's remesher is an extremely useful processor. In games like Halo Infinite, it is used to merge large vistas that can be switched in when the player is far away from them, saving performance for the things that are closer to the camera. For example, this pile of rocks are hundreds and thousands of polygons before the remesher does its magic. After the process, it's just a fraction of the original and can now be used to represent the collection in the background. If we zoom out here a bit and switch between these, you can see that it's barely distinguishable which one's which. The remesher also has a lot of other interesting use cases, such as producing collision geometry or just to create thumbnails in an asset library. And with that, our visit to the Simplygon Park is over. As I mentioned earlier, make sure to catch our deep dive talks for a more detailed run through. If you want to learn more about how to use these features to optimize your game, visit our website, simplygon.com, or browse through our tutorial videos at Simplygon's YouTube channel. Thank you for watching. Bye.